Hello. So in this first exercise, we're going to do some introduction to grasshopper tools in Rhino. We are not going to actually draw any geometry in Rhino. Everything will be done through grasshopper. So I'll be giving you a breakdown of some of the fundamental principles, how to navigate grasshopper tools, and also kind of the basic workflows of parametric design in this simple exercise. So we are going to generate a bunch of parametric models, and our end goal will be to do an attractor-based wall paneling, and we're going to look at some main aspects of how that works as well. So let's begin. Let's actually start thinking about the grasshopper interface. First of all, we have a canvas here. So the canvas is basically where we generate our scripts. This is kind of a visual programming environment. It's similar to Rhino environment, but what's different is in Rhino, let's say you're going to create a circle, you actually already do some parametric modeling, and this is kind of a geometry output that you can create. Simultaneously, something like that could be done in grasshopper interface. If you type in circle, for instance, now you have a point and a radius defining a circle, and you can also type in a number slider. So you can see that these two geometries are actually coinciding, and the reason for that is because they're both using the same values for the circle generation. But the difference is that I can delete the Rhino geometry, but I cannot select the grasshopper component. And the reason for that is because this guy is parametrically generated, and if I want to generate it or output it as a geometry to Rhino, I simply bake it. Now there will be a circle there. So if I change the radius, you can see that I can still select that geometry in there. So this goes to show that if we are building something using grasshopper, it's basically virtually modeled. It's a parametric meta model. And if you want to output any variation of it at any time, we use a function called bake. And essentially, we basically build more relationships here in this environment. And as things get more complex, we can basically output more complex models, and things are built hierarchically as well. So we, in order to build lines, you need points. In order to build surfaces, you need lines. And from surfaces, you can get to volumes or extrusions. So things like that, basically things built on top of more primitive geometries. So let's do a simple quick exercise. I'm going to first generate a two-dimensional grid here to kind of get the point of how the canvas works. So we can create a point using construct point command, or you can simply type in XYZ because it takes in 3 parameters. And this is basically, if we create a number slider, you can actually control the coordinates of these points. So this is basically a point with custom X and Y parameters that I'm creating now. And the previous circle that we created, that could also be on the circle, right? So we can actually have a parametric circle here too. Now, one thing that I want to mention is when you highlight these geometries, you can see that some of them are highlighted in green. That's because we have a document preview setting. It's basically if you select any grasshopper plugin, the geometry it generates is highlighted in green. You can also change it to be any other color you want, or you can just simply pick a color. Let's keep it at this blue tone. So now everything that I select here will be highlighted in blue. Now, if I don't want to show anything, you can simply right-click here and disable preview. That will turn this element into darker gray tone. And if you don't want to basically, if you don't want this to work, you can right click and disable it. So now that will basically work almost like an off switch. So technically speaking, this won't feed in any data, and we won't be sending in any points here, so that the circle is right now orange. It means it basically doesn't receive any data. The other problem might be that you can also have a case like this. For instance, let's say we have a panel that doesn't have any value and we assign this here. Now you get a plugin that's showing red. That means this is producing an error, and it's showing you it's basically cannot convert text to number, right? So a few things we can have. We are working with these kind of plugins or these kind of generators. Inside they make geometries, they produce rules or text or any type of parameter that we need. You can turn on their visibility by turning on preview or turning it off. You can disable their preview. You can right click and disable it in order to kill the plugin, or you can simply basically, if you don't want to you don't want it to generate anything, I mean, if you have any issues, it might also get this red condition, right? So if you don't receive any value, it turns into orange. If there's an error, it gives you a red signal. So these are kind of the basic visual inputs that we can read from Grasshopper. So now that we know how we can work with points, let's actually look at these lines here that you can see. These are basically how we connect certain plugins with each other. So these are basically assigning values to each other. And in order to know what you need to connect, you can hover over these points or these locations where there are input or output. It actually tells you what it needs. So this is radius of a circle. This is the base plane of the circle. So this could be a point or a plane, and you need to supply appropriate geometry or information so that these things could work. Okay, so now let's create a grid of points. For that, I'm going to use series. Series is located under sets sequence, and it takes in a starting value, step size, and a total number of counts. So you can basically start from 0. Keep the step size as 2. You can just double click on the canvas and type in any number value that you want. So now if we connect this to another construct point but along the x dimension, you can see now we have more than 1 points generated. So I'm going to kill this script here so that we can focus on this part. You can use the mouse roller to actually zoom in, zoom out of the script. Use panning to move around. So for this one, I want to create a point grid. So let's look at how we can do that. I'm going to make a copy of the series and paste it. You can also make any amount of copy paste. You can simply use your keyboard to make that happen. And one trick you can use is for the number sliders, you can actually right click here and go to edit and customize the intervals manually here if you want it to be kind of a value with a decimal, even or odd number. I'm going to keep them as natural numbers, and you can customize the minimum maximum values. You can also do it by using a shortcut. For instance, let's say I want to have a slider from 5 to 15. So I can type it up like this as a shortcut, and that will give me a slider with that interval. So it will go from 5 to 15. You can also do it with a decimal. So you can do, for instance, 2.0.16. So that will have a single decimal, and it will go from 2 to 16. So this will be the second series. Now I have 20 values going to x. Let's say if I want to have 5 values going to y. So this is what happens actually. So let's look at in detail what this is. So why do we see something like that? So I'm going to connect 2 panels here to look at the data. So the list on top has 20 values. The lists always start with an index of 0. On the left you can see the indices. The second list has 5 values. So since there's asymmetry between these two lists, we are actually getting what we call as a short list. So basically, the indices that match are correlated with each other, but after the second list is exhausted, the last value gets matched to the remaining items in the list. So if you increase this, you will see that the data is matching more and more because the data is getting correlated. But the problem is when you have different number of values here, this will happen. So in order to create a two-dimensional grid, what we can do is correlate this information. And to do that, we can use cross-reference. So what cross-reference does is it basically gets in two values and creates a list that basically uses or multiplies the corresponding values according to the second list. So in this case, A will be the multiplications of the data that comes from A, and B would be the multiplication of data that comes from the list B. So that will make a cross-reference list, almost like a two-dimensional grid. So now if I want to create a circle along these points with a radius of, let's say, 1, actually let's make it 2.5. Now these would be basically the circles. So all these points can have basically a circle now. So I'm supplying 200 points. For this exercise to work, we're going to create an attractor, and we're going to basically override the radius values of these circles. This is kind of a simple exercise, but we're going to do it almost like a wall condition later, so that we can actually test these as almost like apertures. So in order to do it, we need to have some more control over how the radius values are distributed. Right now you can see that we are basically giving one single parameter to the radius. Here you can see that we have a rectangular grid or a square grid, so we can also use same sliders to control the dimension of the grid size. And since the grid size is 4, we can actually have the radius as half of this. So I can divide, add a division here. So I can divide the number slider by 2. And that will basically associate the radius value with the grid size. So now even though I scale up or down, the radius values would always be half of the grid size. Now the reason why I want to do it is because I want to see the behavior of the radius values. So let's say that we have a point here, somewhere here. I said I didn't want to create any geometry in Rhino in the beginning. So let's actually make this, we can actually do it in a bunch of ways, but let's make it as a point. And I want to have a huge value for X and Y. So let's say 200 by 200. So this would be, let's see where that point lies. So this is actually 200 was too much. Let's say 50 by 50. Okay, so right now we are off the grid. So let's move it onto the grid. So this is where our point is. We can also increase the grid sizes a bit. Now what I want to do is have the radius value as a parameter that is influenced by the distance to this point. This point will be almost like a target. So one way to visualize it would be if you drew a line from each grid point to this point here, you can see that we have lines at different lengths, right? So these lines would basically correspond to the distance of the grid points to the attractor point. So I can also do a distance here. So grid points to the point, and this will give me all the values of the distances. So for instance, if I directly plug these in, you will see that the circles blow up because some of the values are too much. So I can simply do a division here, and let's divide it by 100 so that we get really small values. And this is already giving me some sort of parametric behavior. I'm going to turn off this line here for a second. But you can see that I don't have much control over the grid other than just having this coefficient of division, right? So when I move the point around, I get some sort of behavior. But I also get circles overlapping, or they're actually intersecting. So what if we don't want them to go beyond some sort of threshold? How do we achieve that? So in order to explain how to do that, we basically need to set up kind of a threshold for these values. So they already have a minimum and a maximum value. So to see that, we can do bounds. Bounds basically shows us the minimum and maximum values inside of a list. I can also assign a panel here so that we can see the output. So right now the values go from 0.08 to 2.53. So what I want to do is actually set up a restriction for the upper limit. So our grid size is defined here. So we are starting with 4, dividing it by half. So I don't want the radius value to be larger than 2. So this is my upper limit. So here I'm going to create a minimum threshold, which basically means for all the distance values that I get from A, I'm going to compare them to 2, and if they are larger than 2, they will be replaced with 2. So at the end of this operation, if you look at the new bounds, the upper limit will be limited to 2, because for those of values that are greater than 2, they will be filtered out. And now if I put this in as my radius values, you can see that the circles here that were overlapping there now don't do that, right? So we are kind of restricting the maximum size of the circle. Let's do the same thing for the smaller circles here. So for that, I'm going to do maximum, so which is kind of intuitive, I guess. So I'm going to set up a lower threshold of 0.5. This could be just a random value. Right now 0.08 is too small, so I'm going to make it, let's say 0.2. And by the end of this operation, our interval will be set to 0.2 to 2. So now if I feed this in, all these small circles will be limited to 0.2. So you can also increase the sizes here and see the behavior. So now we have some control over the how the point influences the field, the maximum radius values and the minimum radius values. And you can also move the point around to see the behavior. So we can control the grid sizes. We can control the number of points in the vertical and the horizontal direction. You can also control the location of the point. So that will be basically the simplest parametric exercise we can do. But I'm going to take it a step further and do it almost like a wall and see if we can actually add some more features on top of it. So it's going to be a bit more interesting now. So now that we have done this, I'm going to disable it, and we can actually start with the point grid again. So I'm going to make a copy and paste. So let's start a new example. So I'm going to start with the point grid. So what if we use the attractor again, but instead we want to use, we want to get some sort of surfaces or models here. How can we achieve that? So let's actually try to place rectangles in order to fill this area up. So I already have points here, and I want to do rectangles this time. The way rectangles work is they have a plane and they have X and Y intervals. So basically we need to specify the X dimension and the Y dimension as almost like an offset value. So we need to use construct domain for this case. So since we have a square grid, we can actually do, we can use 5. You can also break this up, but I'm going to do it later. So we can do division. You can divide 5 by 2. So now my value is 2.5, and I'm going to connect it to A and connect it to B. But you would realize that x is going from minus to plus. It's because this is the center of the rectangle, and we're going -1 to the left and +1 to the right to define the left and right interval for the rectangle. We can simply multiply this value by -1 and assign it to A, but there's also a shortcut to do it. You can simply right click to A, go to expression, and here type in -x. So that will basically multiply 2.5 with -1, and that will give you 2.5. So our interval will be -2.5 to 2.5. So if I connect this to x and connect this to y, I get a square grid now. So I'm going to make another copy of this point attractor. And this time I'm going to scale the rectangles using their distance to this point. So we can grab the distances of the grid points to the attractor point. And rather than doing this minimum, maximum, and division coefficient, I'm going to show you something else that you can do, which is called remap. So what remap does is, imagine we have a list of values that are within an interval. So I can find their interval using bounds. So the values that we have are between 2.82, sorry, to 99.3. So this will be the source domain. This is basically, I'm defining the upper and lower threshold for my values. These are the distance values, and I want to map them onto another domain. So that domain could be customized. So let's do a construct domain. So construct domain basically gives us an interval with a lower and an upper threshold. So let's say I want my values to go from 0.2 to 0.8. So 0.2 will become almost synonymous to this minimum function. 0.8 will be similar to the maximum function here. And if I put this as my target value, now all the values will be mapped between this interval, this new interval. And I'm going to use them to scale these rectangles down. So I'm going to do scale. So these are the geometries I want to scale. Their centers of scaling will be their grid points, and their factors will be here. So now we basically have scaled rectangles inside these grid points. So now if you move the point, this is also visible. I'm going to disable that. So you can see if I move this point, now the grid cells are actually changing. Now we are not having any type of division or control, but this would actually help us to control the mapping. If you want it to be going from 0.1 to 0.9, you can have more drastic behavior. Let's actually model these as basically surfaces. So one way to do it would be to join these two elements together. So one way to do it is merge. So if you merge these rectangles with these rectangles, that normally adds two lists back to back. But you can also do a small trick here. If you right click here and do graft, what that does is it puts each rectangle into groups of 2. So now the scaled down version and the larger border would actually be matched. So if you do a loft or a boundary surface, now you will get the full surface forming. So now if I move the point, you can see the cells, the surfaces are actually changing. We can actually add a bit more to this. You can also scale things down and move them up. For instance, I'm going to disable this part, come down here, type in move. Let's say that we want to move these elements upwards in the Z direction. And I can create another VMap value here. And this time I can make the target domain to be between 1 to 4. So these will be how much these scaled down rectangles will be moved upwards. So now you can see there's also some sort of groove, because the smaller the rectangle, the less it moves upward. You can also make this a bit more higher, like this. Now if I replace the scaled down versions with these, turn on the loft, enable this, now you can see we have something three-dimensional. So I'm going to bake this so that we can look at it, but we basically created almost like a screen. So let me actually turn off what's happening in the back. So there you have it. This was kind of our first exercise with the attractor field, and you can actually test this with circles and rectangles.